Okay. Good evening, all of you. My name is Sumit Sagar Hota. I am a PMRI PhD scholar, IIT Palakkad. Today we will discuss week 6 of the live discussion section, in which we cover lecture 26 to 30 by Professor Ashok Desai, IIT Kanpur, of the subject Introduction to Air Breathing and Propulsion. Okay. So here very few subjective questions are there and two very long questions are there. Okay, that I will cover. Okay, in that long question some parts will be there. Okay, those parts can be the short question. Okay. The prerequisite for this section is you have to at least watch 26 lecture 26 to 30 by Professor Ashok Desai. Okay. Okay. Let's go to our first question. The axial flow of turbojet have about dash less specific fuel consumption. Okay, so this is a kind of subjective question. Okay, so in this kind of question, if you actually know the answer, then try to attend, otherwise not try to attend. Okay, so the answer for this question is A. Okay. Axial flow of turbojets. Okay. Six to 8% of sometimes in question it's only written SFC, but this also means specific fuel consumption. Okay, so the answer is A. The basic cycle for turbojet engine. Okay, this is very good question, it can be asked. Okay, so mostly the first answers for the student will be Brayton cycle. Many of the people know that the basic cycle for the turbojet is Brayton cycle. Okay, because it's a constant pressure cycle, so most of the people knows. Okay, that's the reason this question is set such that because most of the people may not know about the Joule cycle. Okay, it is not commonly used cycle. Okay, so that's the reason this confusion arises. Okay, so the answer is both A and B. Okay, Joule cycle is also the we will also use the Joule cycle. Okay, so this is also a very good question. Okay, so now the turbojet engine is a dash. Okay, is it a continuous or non-continuous? Okay, so any kind of jet engine you always know that is always continuous. Okay, so they can ask like ramjet is continuous or not, turbofan is continuous or not. Okay, so try to for confusing you. Okay, if the answer is also question is also jet engine is continuous or not, then also that is also correct. Okay, jet engine is a continuous flow engine. Okay, any of the jet engine. Okay, so answer is continuous. Yes. See. So turbojet engine is a continuous flow engine. Okay, the turbojet engine is eminently suited for propelling aircraft at a speed of what? Okay, so this kind of questions are very common. If you know the answer, then you just attend, otherwise don't attend. Okay, so actually when this kind of questions are there, okay, that means they know their point means giving importance on two number, one is 800 and one is 300. Okay, so they are giving importance on these two numbers. Okay, so that means you will know that the answer will be either 800 or 300. Okay, if you can either means deduct it's 800 or 300, then you will only have two options to get the answer. Okay, so as in the previous sections I already told, 300 is already for the what, ramjets. Okay, so if you know this, if you remember this, so you can very easily cancel these two options. Okay, so now you have 800 above and 800 below. Okay, and one thing you always remember, okay, whatever the jet engines are there, okay, we don't know what is the maximum limit. Okay, so how much power it can generate or how much it can propel, okay, in any kind of aircraft. Okay, so maximum limit nobody don't know. Okay, but yes, the minimum how much it can go minimum, that we know. Okay, so that's what the idea. So we know the minimum value is 800. Okay, above that it can go any height. Okay, similarly for the ramjet, this 300 is the answer, because above 300 is the answer for ramjet. Okay, this is for ramjet and this is for your turbojet. Okay, so this is what the idea. So the answer is A. Next question. The turbofan engine was originally conceived as a method of improving the dash of the jet engine by reducing the mean jet velocity. Okay, so okay, so turbofan is the main. So here turbofan came. So then what is the thing? Jet engine is reducing the mean jet velocity. Okay, you see efficiency. So question efficiency is the question. turbofan is the turbofan is the thing, and efficiency are the questions. Okay, so that means if you know yes. So okay, so okay. Uh, so you see, so in the in this question, turbofan is the catch and efficiency is the catch. Okay, so 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 that means if you know which efficiency should be the correct option, then it will be the your answer. Okay, so that's what the idea. So you know very well the turbofan engine was originally conceived a method of improving the dash of the jet engine by reducing the mean jet velocity. Okay, so when these kind of questions are there, okay, mostly if you see this is the basic definition of turbofan engine, why this turbofan engine is invented. Okay, so that is what the this question about. Okay, so we know this turbofan engine will reduce the mean jet velocity. This can be also one question. Okay, reducing the mean jet velocity is also one question. Originally conceived as a method of improving. Okay, so you see, always remember when in any kind of question, method of improving one word is there. Okay, method of improving one word is there. Okay, then there never be the option of overall efficiency. Okay, because in the question thermal efficiency, propulsion efficiency is there in the option, and then overall efficiency cannot take place. Okay, because you know in the formula overall efficiency equal to what, propulsion efficiency into thermal efficiency. Okay, so if you know this formula, then this thermal efficiency having no means this overall efficiency having no use. Okay, so that is the first thing you have to think. Okay, means how you will approach this question. Okay, if you don't know also anything, this is how you will approach. Okay, now the method of improving, okay, it can be method of improving thermal efficiency can be taken into existence, and it can be also propulsion efficiency. Okay, so okay, so now what the thing is in the question, what is written, by reducing the mean jet velocity. Okay, so they are talking about the reducing the velocity. Okay, so velocity is coming into existence. Okay, so if you know in any kind of in this kind of question, why I am just stressing on all these things, because in this question itself the answer exists. Okay, so I just cross this overall efficiency, none anyway cannot be the answer. If none is the answer, then why they are giving the question? Okay, mostly none cannot be the answer, sometimes also none can be the answer. Okay, so now propulsion efficiency and thermal efficiency we need to take which is the correct answer. Okay, so you see propulsion efficiency, you see now I told the jet engine by reducing the mean jet velocity. Okay, so reducing mean jet velocity, one statement they just given. Okay, so they are talking about this when this turbofan was originally convinced, or initially invented, okay, or proposed. Okay, it will reduce your mean jet velocity. Okay, if it reduce your mean jet velocity, that means velocity came into existence, and that to not normal velocity, mean jet velocity they are telling, mean jet velocity. Okay, so mean jet velocity is where this mean jet velocity will come. This mean jet velocity only come in the propulsion efficiency, it cannot come in your thermal efficiency. Okay, so that's the reason why this thermal efficiency cannot be the answer, and propulsion efficiency will be the answer. So in this kind of question, when this somewhat long questions will be given, so you have to read these questions very carefully, don't go very fast in this type of question. Okay, and then solve it. Okay, so Okay. Okay, so answer is here. The turbofan engine are usually described in terms of what? Okay. So in this question we will see what about this bypass ratio, bypass factor, what is bypass, all these things. Okay. Okay, now turbofan engine. Okay, so whatever this question, turbofan engine is there. Okay, so turbofan engine, if it is there in the question, so answer will be always bypass ratio. Okay, bypass factor not come into existence. Okay, so that's what the idea. I am just telling you what is exactly this bypass ratio, all these things. Okay, so let's remember bypass. First I will discuss your bypass. Okay, what is bypass? Okay, so first of all you should know one thing is that there is two terms, always remember. Okay, one is here bypass ratio. Okay, wherever you go, okay, in thermal science, okay, there is two terms always come into existence. One is bypass ratio and one is your bypass factor. Okay, there is no bypass single stage. Okay, there is no, only bypass is not existing here, none cannot be the option. Okay, because we have the options bypass ratio and bypass factor. Okay, so from this ratio and factor we have to choose one of the option. Okay, okay, so now first I will tell what is bypass factor. Okay, in short form sometimes they will write down as BPF. Okay, what is this BPF? Okay, so for example, there is one, we need one more page for this. Okay, so bypass factor. Okay, so bypass factor is not our course, because the answer I already told you is the bypass ratio. Okay, but if you don't know what is bypass factor, then you may confuse in your examination. Okay, so that's the reason I am only teaching you what is exactly this bypass factor is, so that you can never confuse in your any kind of exams. Okay, so okay, what is first bypass factor? For example, one duct is there. Okay, maybe this is a adiabatic duct. Okay, it may or may not be adiabatic. Sometimes, most of the time, it is they will represent it as adiabatic. Okay, so that no heat transfer. Okay, okay, so now here one heater coil is there. Okay, okay, so that means in this heater coil having let it the temperature is Ts. Okay, so here let the inlet temperature is Ti. Okay, and outlet temperature is T out or TO. Okay, so what is the bypass factor then? So the bypass factor is equal to Ts minus T O divided by Ts minus Ti. Okay, so what does it mean? Okay, so okay, so this is what the idea. Okay, what does this exactly mean is that bypass factor, okay, for example, let's say we can draw, for example, we want to draw. Okay, this is mostly this bypass factor come in the psychometry. Okay, if you know in thermodynamics there is one chapter called psychometry, or it more specific it's come in the refrigeration. Okay, psychometric chart, all these things. Okay, there exactly this bypass factor will come. Okay, but they can twist you like this also, because if they want to twist they can twist you, okay, very easily. So okay, for example, TS will be your temperature. Okay, from inlet to outlet your temperature remains constant, but the inlet to outlet the temperature rises. Okay, 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 this cannot be your Ti. Ti may be equal to your T ambient. Okay, it may not be 0. Okay, so this is what the, let's show the graph. Okay, this is for what? Heating coil. For example, if it is not the heating coil and if it is a cooling coil, then how it will be the graph, how the graph should look like. So this is the graph and it will look like this. Okay, this is your TS, this is your Ti, this is your To. Okay, so accordingly you can modify this formula. Okay, that means what it will be, maybe this minus sign or something will come. Okay, this is for heating. So for cooling coil, what it will be. Okay, see, just reverses, because To is more, na? So To minus Ts divided by Ti minus Ts. Okay, that will be the case. Okay, so this is why I am telling all this thing, because it's give you an idea what bypass factor is. Okay, so just now write down what is the definition of bypass factor, then we will go for bypass ratio. Okay, so the bypass factor is equal to temperature drop or increase not achieved. Okay, because of Ts, is it possible that whatever the temperature Ts is having, is possible that this air also achieve the same temperature? It's never be possible. Okay, some resistance will be there. Okay, it's not possible that it will exactly achieve the same temperature. Okay, if you put on heater in your room, and we can for example, it's the heater temperature is somewhere around 50 degrees Celsius. Okay, and our and inside temperature initially maybe 10 degrees Celsius it's there. Okay, so the now when this heater will be put after 1 hour or after 2 hours, so the temperature will rise to maybe 20 degrees Celsius or 30 degrees Celsius. Okay, at the infinite only it will be what? At the infinite only it will touch. Touch means at the infinite only both the graphs will be means both having same temperature. Okay, so that's what the idea. Okay, so this is it's written never achieved. Okay, it will achieve only at the infinite. Okay, so divided by temperature drop or increase that could be achieved ideally. Okay, so this is what the definition of your what bypass factor. Okay, this is mostly there in a psychometry. Okay, so now you don't need to worry about what is bypass factor. It's not going to be in this course. Okay, but you should know, because this question may come in your, means this kind of confusing question will come then you may struggle. Okay, so now we come to our major thing, that is the bypass ratio. Okay, which is the correct answer. Okay, your bypass ratio BR is equal to flow through the bypass duct which is the what? Cold stream divided by flow at entry to the high pressure compressor. Okay, which is hot stream. High pressure compressor never be cold. Okay, it's always hot, because of high pressure the temperature will rise. Okay, Boyle's law, T directly proportional to P. So this is what the idea. Okay, this is what the bypass ratio is. So formula, if you want to write down, MC by MH. This is your bypass ratio. Okay, so flow through the cold stream, MC divided by MH is your hot stream. Okay, M dot C, M dot H. Okay, that's the idea. One very good expression you should know. Okay, maybe some questions can be asked. Okay, some small questions. What is the relation M dot C? Cold stream. Cold stream mass flow is equal to total mass flow into your bypass ratio divided by bypass ratio plus 1. Okay, similarly mass flow through the hot stream is equal to what? M dot total divided by bypass ratio plus 1. And what is your M dot total? Is equal to M dot cold stream plus M dot hot stream. Okay, so this is what the difference. Somewhere it's showing the different ratio of the temperature, somewhere it's about the flow. Okay, so this is what the difference between your bypass ratio and bypass factor. Okay, so for this question, the answer is A. Okay, so why you take this question long time? Because in this one question, two or three questions can be answered. Okay, now very easily you can answer directly, because I already told you everything. If you try, means already I show you now 1 second before the answer. If you try to answer this question, bypass ratio defined as the ratio of the flow through the bypass duct to the flow at entry to the dash. Okay, so you can try just 1 second before I just tell you the answer already. Okay, simple na, I already told you. See here I shown the formula. Bypass ratio is equal to flow out through the bypass duct cold stream divided by flow at entry to the high pressure compressor hot stream. Okay, so cold to hot is the answer. Okay, so now what is the answer? Answer will be here. High pressure compressor hot stream. So answer is A. Okay. Explanation I already given. Still I'll put this. Okay. Next question. The term turbofan was originally used for the engine of high what? Okay, so if turbofan is the your question, and in the option bypass ratio is there, don't read everything. Bypass ratio will be your answer. That's it. Okay. Turbofan was originally used for high bypass ratio. Okay, so now let's start with the problems. There is total 2 problems are there. Okay, long problems are there. Okay. Okay, determination of the specific thrust of a and specific fuel consumption for a simple turbojet engine having the following component performance. Okay, at the design point at which the cruise speed and the altitude are m equal to 0.8 to 10,000 meter. Okay, the compressor pressure ratio equal to 8, turbine inlet temperature 1200 Kelvin, isentropic efficiency of compressor 0.87, turbine 0.9, intake 0.93, propelling nozzle ni equal to 0.95. Mechanical transmission. Okay, so the mechanical efficiency Nm equal to 0.98, combustion efficiency Nb equal to 0.98. Okay, and the combustion pressure loss equal to 4%, whatever. Okay, so this is a very big question. We just solve it accordingly. One values we will put it and solve. Okay. Okay, let's go. Okay, let's go. Okay, so for this question what you can do, So some of the values are the 10,000 meter, okay, because here the height is 10,000 meter given. So some of the data you have to find out, like basic properties like pressure, temperature, okay, and what is the sonic speed, everything, okay. So this may be in the, okay, a 10,000 meter, okay, PA is equal to 0.265 bar, okay. TA is equal to 223.3 Kelvin. A is equal to sonic speed 299.5 meter per second, okay. Now you have to find out the stagnation condition. This kind of questions you will expect in your mains examination of IAS or kind of thing, and short questions in your NPTEL directly it will be asked, okay. The CA square divided by 2 into CP, okay. So why this CA square we just find out, because the stagnation condition you have to multiply with what, your Mach number, okay. What is the cruise speed? 0.8, okay. So 0.8 into what will be your sonic speed? A 299.5. So what is the CA square? Okay, it will be the multiplication of your Mach number and your sonic speed. Sonic speed 299.5 whole square divided by CP. You know, converted into joule per kg Kelvin. So multiply by 1000. Okay. So the value comes out in terms of Kelvin, 28.6 Kelvin. Okay. So why we just found out, because we use it in the formula of T01, T01. Okay. Okay. Before that, you should know why we are doing all this. So for that I have to first plot the cycle, okay. just a second. Okay, so let's plot the cycles. So here this is very complicated. Okay, so now here it will come 1, here it will come, and here it will come, and here it will come. Okay, so this will be your ambient. Okay, this is your 1, this is your 2. Okay, this temperature difference is your delta PB. Okay, so you get 1, 2. Okay, now 3. Where is 3? Here is 3. Three, 4, 5. Okay, so this is what the idea. So okay, this much only is enough. Okay, other things I will just come directly. Okay, so if I write down many things, then it will be a confusion. Okay, so then what is this T1? The T1 is equal to TA plus CA square divided by 2CP. These are all formula for turbojet. Okay, engines. Okay, so 223.3 plus 28.6 is equal to 251.9 Kelvin. Okay, get it? So now what is P01? P01 by PA is equal to 1 plus efficiency I, not efficiency I think this is in the inlet, I think, yeah, intake, Ni plus Ca square divided by 2Cp into Ta. A means your ambient. Okay, so gamma by gamma minus 1. Okay, gamma is your 1.4. okay, air. Okay, so don't write not, okay, just only P1 is enough. Okay, so then we have to just substitute our values, whatever the values we have, then we can find out what is P1. Okay, so P1 by PA is equal to 1 plus what is Ni? Ni is your 0.93. Ca square, already Ca square Ca square divided by 2Cp. Okay, Ca square divided by 2Cp already we found out. Okay, here you see Ca square by 2Cp is 28.6. okay, so 28.6. okay, divided by what is the value we need? Ta. What is Ta? Ta is your ambient temperature. What is ambient temperature given? Where is it given? Not given. That means we have from the what, some tables, 10,000 meter, 223.3 Kelvin is your Ta. Okay, so divided by 223.3. okay, to the power 3.5. okay, 3.5 why? because 1.4 divided by 0.4. okay, if you do it, the value will be 3.5. okay, so now this value comes out to be 1.482. okay, now what is P1? Because you know PA what is PA? 0.265 bar. okay, so 0.265 into 1.482. okay, implies, so P1 will be your 0.393 bar. okay, so in here up to now 2 questions can be asked. First question they can ask you is that these are the conditions they will give. They will ask you what is T1. okay, so what is T1 will be your first question they will ask. okay, and the second question they can ask will be your P1. okay, so T1 and P1 are the 2 questions. okay, this is at the what stagnation condition after the intake. okay, may be obtained as follows. okay, after stagnation condition the intake is there, so intake conditions is there. okay, now we go to next what outlet of the compressor. okay, so at the outlet from the outlet from the compressor. Outlet from the compressor is what? It is the formula. So P2 will be the outlet from the compressor. Where is P2? You see the graph. P2 here is the P2. So P2 is the outlet from the compressor. okay, so you know the ratio na? Yeah, you know the ratio. Compressor pressure ratio in the question it's mentioned is equal to 8. okay, compressor pressure ratio is equal to 8 is already mentioned in the question. okay, so if it is mentioned in the question, we just use it. What is the compressor pressure ratio? So we need to find out P2. yes, so P2 we need to find out. P2 is equal to what? P2 by P1 into P1. yes or no? yeah, so what is this P2 by P1? Your compressor pressure ratio. which is given what? 8. and what is P1? P1 we already find out what? 0.393. so just substitute here. okay, so what is P2? so this can be also one question. If they given you in the question, they will ask you both P1 and find P1 and P2. okay, maybe a 2 mark question they will ask. okay, so now next let's go to what? T2. okay, or maybe T2 minus T1, more specific. Directly you cannot find out T2 because we don't know what T1. yeah, we know the T1. yes, you know the T1 I think. yes, we know the T1. If you know the T1, then we can find out the T2. Let's first discuss what is the difference between the T2 and T1. okay, what is the difference formula? okay, between T2 and T1. Okay, so the T2 minus T1. Okay, see, first what we done, first we see what is TA in this question. Okay, for the what turbojet engine. Okay, these are the things given. You see, these are the things for the atmospheric condition. Okay, we first find out T1, then we find out P1, then we find out P2. Now we have to find out T2. Okay, each one will be the one short question in your examination. Okay, so you should know what is the ratio, the difference between T2 and T1. Okay, difference of T2 by T1 equal to T1 by efficiency of compressor P2 by P1 to the power gamma minus 1 by gamma. These are all the formula for your turbojet engines. Okay, you should remember all these formulas, then only you can answer these questions. Okay, what is T1? T1 is 251.9 Kelvin. Okay, what is NC? Or ITC is the what isentropic efficiency of the compressor. Okay, what is P2, P1, everything given. Sorry, we already find out. P2 3.144, P1 0.393. Just substitute gamma 1.4. Okay, P2 by P1, don't need to directly put, also directly the ratio in the question given. Okay, compressor pressure ratio is equal to 8. Okay, it's already given in the question. Okay, so directly 8 gamma minus 1 by gamma, directly write down. It's 1.1 by 3.5 minus 1, because 0.4 divided by 1.4, if you do, it will be 1 by 3.5. If you solve, this difference will come to 34.9 Kelvin. Okay, but you know what is T1? T1 is your 251.9. It's already given. So what is T2? 251.9 plus 234.9 equal to 486.8 Kelvin. Okay, so now we found out what T2. Now if you know T2, okay, so now let's go to your turbine. Okay, so 1 2 over in the graph, you see, where is the graph? Yes, 1 2 A 1 2 over. Now we go to the turbine 3 4 5. Okay, turbine, nozzle, all these things we now will go. Okay, diffuser, compressor over, nozzle, sorry, turbine, nozzle. Now is the case. Okay, so now we know one relation. Okay, work done by the turbine is equal to work done by the compressor divided by Nm. What is Nm? Nm will be your what? Thermal efficiency. Okay, sorry, mechanical efficiency. Okay, They're not thermal because because both the compressor and your what uh, uh, sometimes in place of this mechanical efficiency they will write down shaft efficiency. Okay, you don't confuse, both are same because in the compressor and turbines are connected through a shaft. Okay, sometimes the turbine shaft efficiency like that they will write down. Okay, that's the same mechanical efficiency. Okay, so we know. So now we just write down the difference, T3 minus T4, the formula. Okay, so how this thing will come directly difficult. Okay, just write down from the starting. Okay, so what is WT? CP of maybe G, T3 minus T4 is equal to, what is for compressor? CP of A, ambient. Okay, T2 minus T1 divided by mechanical efficiency. Okay, okay. So CPA, CPG, okay, CPA, CPG, CPG will be your okay. So okay, so just this thing CPG also you need to know, but CPG values are not given. Okay, so what we will do, okay, in the question CPG value not given for the turbine. Okay, but they should give the values. Okay, so in this kind of question if you don't know anything, just assume both are the same. Okay, since I know what is the CPG, okay, so I just write down. Okay, if they don't give, write down the same. Okay, so T3 minus T4 is equal to, so TCP of air 1.005, T2 minus T1 already you know 234.9, the difference we already know, divided by, okay, CPG we should know. Okay, if it is not there, okay, we write down CPG is equal to 1.148 kilojoule per kg Kelvin. Okay, this should be given on the question, 1.148, okay, into efficiency, mechanical efficiency. What is the mechanical efficiency given? 99.99. okay, mechanical transmission efficiency 0.99%. okay, okay, so now what is T3? You know T3? Yes, you know T3. It's written turbine inlet temperature 1200 Kelvin. Okay, it's written. Okay, so what is turbine inlet temperature? This is the T3 is the turbine inlet temperature, na, highest temperature. Okay, just substitute now. Okay, so what is T4? Okay, first of all you need to find out this value. What is this value? This value comes out to be 207.7 Kelvin. Okay, you know what? T3 1200 Kelvin. What will be T4 then? 1200 minus 207.7. Now what will be the value? 992.3 Kelvin. Okay, This is what the idea. So now you know T4. Okay, so it can be a question. What is T4? They'll give you everything. They'll give you T3. They'll give you all the CP, CPG, CPA. Okay, mechanical efficiency, everything they will give. Then they want T4. Okay, this can be one question. Okay, so now there is one twist. Okay, so what is now P3? We need to find out. Okay, P3 is what? P2 into 1 minus delta PB divided by P2. Why this delta PB came into existence? If delta PB not came into existence, then what? P3 equal to P2. Okay, you see, in the question it's mentioned that the combustion pressure loss 4% compressor delivery pressure. Okay, so there is one loss in the pressure from the compressor. Okay, so that's the reason it's not matches. Okay, P3 not equal to P2. So this delta PB came into existence. Okay, so just substitute all these values. Okay, P2, I think you know. What is P2? First, where is P2? Yes, here is P2. P2 equal to 3.144 bar. Okay, what else you need? Delta PB 4%, 0.04. Okay, so everything you know, the substitute. 3.144 1 minus 4%, 0.04. P2. What is P2? Okay, divided by P2 is your 3.144. Okay, if you solve, you get the value at 3.018 bar. This is your P3. Okay, so T naught. Now we need to find out what T4 you know. Okay, because here in the question it's given what it's given. In the question it's given the isentropic efficiency of the turbine, okay, is equal to what? 0.9. Okay, this is they are giving. Okay, that means what? That means this is not your only T4 is not going to exist. Okay, but there will be a deviation. Okay, and this will be your 4 dash. Okay, because it's not 100% isentropic. Okay, this cannot be a vertical line. There is some deviation is exist. That point is what? 4 dash. Okay, or 5 to 5 dash, there is nothing is there, so whatever. Okay, so 4 dash is there anyway. Okay, so now we know P3. Let's go for T4 dash. What is T4 dash? Okay, T4 dash related to T3 minus 1 by what? Isentropic efficiency of the turbine into T3 minus T4. This is the formula for T4 dash. Okay, $1200 difference we know 207.7, T3 minus T4. This is your 0.9. What is the difference we know? What is this difference? See, 207.7 we know already. Okay, T3 minus T4. Okay, that I just only substitute. Okay, T3, where is T3? 1200 I already told you. Okay, where is T3? This is your T3. Okay, where is this T3? Turbine inlet temperature 1200 Kelvin. Okay, this is already given. Okay, so everything now given. So just find out T4 dash, which is 969.2. Okay, so that's over. Now P4, what will be your P4? Because you see T3 can be a T4 dash can be a very good question. Okay, they will give you the what isentropic efficiency of the turbine, T3 temperature they will give you, then they will ask you what is T4 dash. This can be one question. Okay, very easy, very good question they will ask. T4 dash. Okay, somewhat twist is there, na? So this question can be asked. Okay, now P4. Now these are simple. P4 equal to what? P3 into T4 dash by T3. This is the twist. Okay, now if somebody forgot to find out T4 dash, okay, and only take the T4 and then put it here in place of T4 dash, if they will put what, he will put T4. Okay, in this formula gamma by gamma minus 1. Okay, and they will calculate what? P4. Whatever the P4 they will get is absolutely what? Wrong. Okay, it's absolutely wrong. That's the reason why we need to check carefully what exactly they mentioned. Okay, so gamma by gamma minus. They can ask you two questions. One T4 dash, second question P4. Okay, if you made T4 dash wrong, then obviously you will make the P4 also wrong. The both will be gone. Both questions are wrong answers. Okay, so you have to very carefully do all these questions. Okay, what is P3? 3.018 bar. Okay, T4 dash 969.2. T3 1200. Gamma by gamma minus 1. Okay, write down 1.4 by 0.4. Okay, if you do all this thing, then you get the value as 1.284 bar. This is your P4. So P4 can be a very good question. T4 and P4, T4 dash and P4 is a very good question. So now they will ask you what? Nozzle pressure ratio. What is exactly asked in the question, na? You see the written determination of the specific thrust and specific fuel consumption for a simple turbojet engine. Okay, what do we need to find out? Specific thrust and specific fuel consumption. Okay, these are the two things we need to find out. Okay, so for that only we are finding all these things. Okay, and in between small questions are coming. Okay, so now what is nozzle? Okay, this is also a very good question. They'll directly ask you nozzle pressure ratio. Okay, what is nozzle pressure ratio? This can be a very good question. Okay, if you don't know where is the nozzle, then you cannot find out where is the nozzle pressure ratio. Okay, so the nozzle, where is the nozzle? First of all you have to know where is the nozzle. You see, you remember always the nozzle will be in the 4 to 1, or here ambient is there, na? So 4 to A, 5 to 1, for 4 to A. Okay, here the nozzle exists at the after the what? After the turbine. So 3 to 4 is the turbine. So after the turbine already the nozzle is there. Okay, so 4 point anyway you will get to know. Okay, so now the confusion will be, it will be go to 4 to 1 or 4 to A. Okay, whatever will be the lowest temperature possible, that there it will go. Okay, that's what the trick you have to remember. Okay, so that the efficiency will be high. Okay, so 4 to A. So that's the reason why this is nozzle pressure ratio question will come. Okay, P4 by PA is equal to P4, you know, 1.284. What is PA? PA is here 0.265 bar. Divided by 0.265. Okay, is equal to 4.845. Okay, this is a nozzle pressure ratio. This can be a very good question. Okay, so now one more very good question, critical pressure ratio. Okay, what is the critical pressure ratio of a turbojet engine? This is also a very good question. Okay, so now for critical pressure ratio, it's not straightforward. Okay, directly we cannot find out the nozzle pressure, critical pressure ratio. For that you have to remember one big formula. Okay, that's what the idea. Critical pressure ratio. In this one big question, lots of small questions are there. Okay, so that's what the idea of this section. Okay, so P4 by PC. Okay, so C can be any pressure. Okay, this PC, what is PC we don't know. Okay, because this is not mentioned in the what graph, but we know one thing is that, okay, PC can be sometimes P5. Okay, so P5 equal to sometimes, where is that P5? Yes, so here is the twist. Okay, so P5 is there na, so here you should write, note that P5 is equal to PA or PC or PC. Remember, P5 can be PA, it can be PC. Okay, not necessarily always PA. P5 equal to PA, not necessarily always P5 equal to PC. Okay, why all this thing? Why this PC came into existence? Okay, PC is any other point. Maybe cold condition you can write down. Okay, so what is, anyway, just remember this formula. Denominator write it down, 1 minus 1 by NJ. What is NJ? NJ is your propelling nozzle. Okay, propelling nozzle isentropic efficiency. Into gamma minus 1 by gamma plus 1 to the power gamma by gamma minus 1. Okay, just one wrong is there, just somewhat less. Okay, hold to the power gamma by gamma minus 1. Okay, just substitute all the values. We know all these values. Okay, here 1 is there. Okay, so I just write down here. No need to, don't want to write down again this thing. Gamma is 1.4. Okay, so when you substitute all these things, you just get P4 by PC as 1.914. Critical pressure ratio is what? 1.914. Critical pressure ratio can be one question. So now you see what is your nozzle pressure ratio, 4.845. Okay, what is critical pressure ratio? 1.914. Okay, one condition you should remember. Okay, what is the condition? The P4 by PA is greater than P4 by PC. Yes or no? It's 4.845 and this is your what? 1.914. Okay, that what does it mean when one okay, what does it mean? I just write down again. This is very now one very good comments will come. Okay, and this comment will be the also one very good question. Okay, one subjective question can be extracted from this comment. Okay, so you see the nozzle pressure ratio, and this is your critical pressure ratio. This is greater than. Okay, whatever the pressure generated in critically, okay, the nozzle pressure is exceeding that. Okay, critical pressure ratio is the highest pressure ratio possible in any kind of turbojet engine. Okay, we cannot exceed this critical pressure ratio. Okay, but here we see that the nozzle pressure is exceeding our critical pressure. Okay, then what does it mean? It means that the nozzle is choking. Okay, so that means nozzle is not going to work. Okay, so this is a very good question. Then that's why I am telling this is kind of a subjective question, because they will ask you if one nozzle pressure is there and nozzle pressure is greater than the critical pressure. Okay, nozzle pressure ratio will be greater than critical pressure ratio. Then what is the condition? The condition is the nozzle is choking. Okay, so that's what the idea. Okay, okay, so the next part, T5. Let's go to T5. Let it be T5 equal to Tc. Okay. What is the formula for T5? 2 by gamma plus 1 into what? T4. Okay, this is the formula for T5. Okay, at the exit of the what? Nozzle. So 2 into what is T4? T4 we find out here. Where is T4? You see T4 dash is here. Don't confuse. Don't put T4 dash. Okay. T4 992.3. Okay, 992.3 divided by okay. So just a second. Okay, one thing we should note here. Okay, when the whatever the well is there. Okay, what is that thing? Yes, in the yes, you see when it is there in the when there is a flow 1 to 2 is there. Okay, here the it is somewhat air. Okay, 1.4 gamma we just take. Okay, but when it's go to turbine, here gamma is also changing. Okay, that's the very good twist in this kind of question. Okay, so when 3 to 4 we just check. Okay, here it's having the gamma of 1.333. Okay, gamma is reducing. That means diatomic gas, monoatomic gas. Okay, so accordingly, because of all these different variables, this gamma is also what? Changing. Okay, so that's the reason why somewhere you see for 1 to 2 here it's act as a gas, and 3 to 4 it will be like a 1.33 means what? Monoatomic gas. Okay, 1 to 2 diatomic and 3 to 4 monoatomic. Why this thing is there it's absorbing? Okay, it may be due to two things. One is combustion pressure loss, one is there. Okay, and maybe due to the what? Combustion efficiency maybe less, maybe because of these two things this may be there. Okay, so because why some place I just write down 1.4, there I have to, you see here I write down wrong. Okay, this is not your 1.4. Okay, so here your 1.33 0.33. Okay, only 3 to 4 whatever it's there, only just remember it's mostly if it is given air. Okay, it's okay. Okay, because this is a what do you call connected question. Okay, 1 2 3 means 1 to 2 2 to 3 3 to 4 like that is connected. Okay, if that otherwise they will, because this is a connected question, so you have to think like that. Okay, but in your question, when you directly one question they will ask you P4, what is P4, what is nozzle ratio, they will directly mention you what is the fuel. Okay, what is the flow medium, everything they will mention. Okay, that's what the idea. Okay, so here it's your 1.33. Okay, 3 to 4 it's your 1.33, and here it's not 1.4. Okay, this is your 1.33. 1.33. Okay, so this is what the change. That's the reason I just wait for some time. Okay. P3. Okay, so now everything now correct. Okay, we just go to the our wherever we just left. Okay, so here now what is the gamma? 2.33. Okay, I told you in the compressor it's diatomic, in the turbine it's monatomic. Okay, so it behaves like monatomic gas. Okay, so this is what the twist in this question. So if you solve it, you get the value as 850.7 Kelvin, your D5. Now what is P5? P5 is equal to PC is equal to P4 into 1 by P4 by PC. Okay, why I am doing all these things? Because we know P4 by PC, what is the value of P4 by PC, and we also know what is P4. What is P4? Okay, first we know where is P4. Okay, let's go. This is your P4 by PC 1.914. P4 is your 1.284. Okay, substitute 1.284 divided by 1.914. What is P5? 0.671. Okay, bar. Okay, okay, now we know P5. Let's go to row 5. Okay, row 5 PC. Okay, PC P5 same. Okay, what is PC? PC P5 0.671, just convert it to what? Kilopascal. So multiply by 100. 1 bar 100 kilopascal. 0.287 into TC 850.7. Okay, because you see here we find out TC is equal to 850.7. Okay, T5 equal to TC equal to this. So what is the answer? 0.275 kg per meter cube. Okay, what is C5? Gamma RTC to the power 1 by 2. What is gamma? Here gamma is what? Nozzle. So 1.33. Okay, and monatomic gas. It will behave like monatomic gas. Okay, 0.287 into TC. What is TC? 850.7. Okay, so but it's in terms of what? Joule per kg Kelvin. But this is what? Kilojoule is there. 10 to the power 3. To the power 1 by 2. What is the value? We will get as 570.5 meter per second. Okay, so C5 we got velocity. Okay, velocity at the what? Exit of the nozzle that we find out. Okay, so C5 we have. Now let's go to A5, or more particularly A5 by M. Okay, what is A5 by M? Is equal to 1 by, this is the formula you should remember, 1 by rho 5 C5. Okay, so what is rho 5? We know 1 by 0.275. Here we know C5 570.5, rho 5 what? 0.275. Okay, substitute. $570.5. If you substitute, you get the value as 0.00634. What is the unit? Meter square. M dot kg per second. Meter square divided by kg per second. Meter square second per kg. Okay. Now we come to our what? Specific thrust. Okay. What is specific thrust? It is Fs. Okay. Okay. So Fs is equal to C5 minus Ca. Okay, plus, this is the formula you should remember. What is the formula for specific thrust? A5 by m into Pc minus Pa. Okay, so all these things we know, just substitute everything. Okay, C5, what is C5? 570.5. What is Ca? Ca, where is Ca? Ca is your what? Ca is your 0.8 into 2.995. Okay, the values comes out to be what? 239.6 if you just find out. Okay, so this is your 239.6 plus what is A5 by M? 0.00. Already we find out above, 6374. PC minus PA. Okay, what is PC? PC is here. Yes, you see, PC 0.671. Okay, here P5 0.671. And what is your PA? PA is here 0.265. Okay, so you know 1 bar is equal to what? 10 to the power 5 Pascal. Okay, so 0.671 minus 0.265. Okay, into 10 to the power 5. Okay, in Pascal we have to find out. Okay, in SI unit. Okay, implies what is the Fs? If you solve everything, you just find out Fs as 589.7 Newton second per kg. Okay, these are the unit of S, specific thrust. Okay, okay, so now we need to find out the what? Okay, so one more things. Okay, um, there is one. Okay, the actual air fuel ratio, okay, or actual fuel air ratio we need to find out. Okay, then only we can find out the what specific fuel consumption. Okay, that's what the idea. Okay, so specific thrust we find out, one question solved. Okay, and one more question is that your what specific fuel consumption. Okay, so that's what the idea. So you see, okay, now you see the fuel air ratio, this value should be what given. Okay, I don't know why it's not given. Okay, the fuel air ratio theoretical is equal to 0.0194. okay, this should be your what given. Or the values are already I think given, you can find out from those values. Okay, 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 so you see here in the question what it's written. Okay, in the question it should be mentioned. Okay, otherwise it's difficult to find out your what, because what is the reaction, what is the things going on, nothing, we don't know anything. Okay, if you don't know anything, then it's very difficult to find out the air fuel ratio. Okay, what is the reaction, everything we don't know. Okay, so what I feel in this question, they should mention the air fuel ratio, otherwise it's very difficult to do this question. Okay, or it cannot be done. Okay, so 0.0194 is must be given. Okay, then only you can find out. Okay, okay, 0.98 one thing given. Yes, so combustion efficiency. So what do you know? Okay, one more question can be asked. Okay, what is NB? Combustion efficiency is equal to, what is combustion efficiency? What is the formula for combustion efficiency? Is equal to fuel air ratio theoretical divided by fuel air ratio what actual. Okay, this is what the formula for what combustion efficiency. Okay, so now what we do, we know what is combustion efficiency. 0.98 is equal to 0.0194 divided by fuel air ratio actual. Okay, so what is your actual fuel air ratio? Is equal to 0.0194 divided by 0.98. Okay, so the values comes out to be 0.0198. Okay, So now it is specific fuel consumption. Fuel air ratio theoretical, actual, divided by what? Fs, specific thrust. Okay. For example, we want it in terms of kg per hour Newton. Okay. Then we just multiply by 3600. Okay. 0.0198 into 3600 divided by 589.7. okay, so is equal to 0.121 kg per hour Newton. Okay. Thing in the question, what it's asked, the determination of the specific thrust that we already find out, and the specific fuel consumption for a simple turbojet engine. Okay, so everything we just find out. Okay. So this is your answer. And sorry, the thrust, this is your answer. Okay, this is enough, I think. Yeah. So time is off, so otherwise I can solve one more question. Okay. Thank you very much for attending the section, and if you have any doubt, just go to my YouTube channel, okay, Sumit Sagar Hota, and ask the doubts, and watch the recorded sections also. Okay. And if there is any comments, just write down in my comment section in the YouTube channel. Okay. And you can ask questions in the question and answer forum. Okay, watch the recorded video very carefully. Okay. Thank you very much for attending the section, or if you are attending the recorded one, thank you very much. Okay, we'll see next week, Saturday, 6 to 8 p.m. Okay, thank you very much and good night.